Okay, now we're going to do our very first example of how to make a Lewis structure. And when you're making a Lewis structure, the very first step is to, after you have your formula, CH2O, is to determine the number of valence electrons in the atom or molecule, which is actually, I wrote it here as number 2, but we typically will do that first. So how many valence electrons does this have? Well, carbon is in column 4. So carbon has 4 valence electrons. Hydrogen is in column 1 and has only 1 electron, but there are 2 of them. There are 2 hydrogens, so 2. And oxygen in column 16 has 6 valence electrons. So this is our total number of valence electrons. These are all our pieces, so that makes 12 valence electrons altogether. 12 valence electrons. That's an important thing to know. Next, we're going to determine which atom should be the central atom. We've got 3 different choices. We could either put hydrogen in the middle, carbon in the middle, or oxygen in the middle. First of all, hydrogen can never be in the middle. Hydrogen is too small. We will do this silly thing I will do with my fingers where I go too small, too small, too small. And that means both TOO, too small, and 2, then number 2, that hydrogen can only have up to 2 electrons because it doesn't have a 1p to put electrons in. So hydrogen can only have up to 2 electrons. It's too small. So it can never be the middle. Hydrogen can never be the center atom. Okay, next it is the one with the lowest electron affinity. The lowest electron affinity. So that's lower and lefter on the periodic table. So lower and lefter on the periodic table. And typically lefter is going to trump lower. But, I'm sure we could find some molecule where that's an exception. But typically lefter is going to trump lower. So we look at C and O. C is to the left. So C is going to be my central atom. So then I'm going to take my central atom and I'm going to place 1 pair of electrons between each pair of bonded atoms to form a single bond. So I'm going to put that central atom in the middle, and then I'm going to put my other atoms around it, like as though they're all going to be bonded to that carbon that's in the center. And I'm going to put a single pair of electrons between each one. So this is representing 2 electrons on each line. That's 6 valence electrons altogether that I have represented here. But I have 12 altogether. Now hydrogen is too small, the number 2. So that means hydrogen will only ever get 2 electrons. So this hydrogen next door to 2 electrons here, that's it. That hydrogen is done. However, atoms like carbon and oxygen can have up to 8. That's the octet rule, that they can have up to 8. Right now, this carbon has 6, 2, 4, 6. This oxygen only has 2, so that's not okay. So step 4, use any remaining pairs as lone pairs around the terminal atoms. So I'm going to say, okay, so I have that already, and I have 6 more electrons. So I'm going to put those 6 electrons around that oxygen. Okay. So we've got 6 electrons around that oxygen. Then I am going to count. Step 5 is to figure out if everybody had the octet rule obeyed. So I'm going to check. This H, has it followed the octet rule? Well, no, but that's because hydrogen is too small and only gets up to 2. So it has like its own unique duet rule. So it's got its 2 and the hydrogen's got its 2. This oxygen perceives that it has 8, 2, 4, 6, 8. So it's satisfied, but this carbon isn't satisfied. It's only got 2, 4, 6 around it. And every atom has to have the octet rule satisfied. And so at this point, we're out of electrons. We can't just tack on another pair of electrons because we only had 12 electrons altogether. We can't make a structure that has 14 electrons just because it suits us. So instead, what we're going to do is we're going to move that pair of electrons into a sharing position so that you have carbon sharing a pair of electrons with oxygen while that oxygen has 2 pairs to itself. Now, everybody's octet rule is satisfied. We've put 12 electrons on the structure, and we're all good. Everybody's happy. Give ourselves a smiley face, or maybe a star, or a hurrah, 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 because we have successfully made our first Lewis structure. And stay tuned for more.